Hello, welcome to Live Coding with Gerph again. This is another one of those sessions where I'm working on my ARM debugger disassembler module for RISC OS. It's a long-running project now, very long-running, we're nearly there really. I mean, we're down to the last few things. So yeah, we've got a lot of bits working. Last week we were working on trying to get some of the CI built and adding in some remaining features, but we're pretty good. We're looking like we've got quite a bit of the work already done now, so that's at the point where I would feel pretty comfortable saying this is done for now. But that's where we are. Let us have a look at the board to see where we're up to. And if we have a look here, we can see that there were a couple of problems. There was a bug that we found last time, which was rather weird. We'll just have a quick look at that. The actual problem here was that the linking of structures was broken. It wasn't relocating them correctly. This was a silly problem. It was the relocation code tries to build a new table of the data that's needed for building the ELF binary into ELF linkage format into the RISC OS absolute file. And in order to do that linking and making it all work together, I was only handling one of the regions that could do relocations. I was only really using fixing the data.rel region, and actually most of the data regions and actually the RO data regions could also be relocated. So there's data.rel.row as well that needed to be fixed up. So I've reworked part of how the linker works. That was build environment stuff, so it's not related to this debugger. So I did that all offline here, and it's now working. So the little fixes that I did to make things static last week are not necessary anymore, but they're still sensible because they're making things static. So this is now done, and as it is done, we can move it over to here. And we were on immediate constants being commented. So we didn't write much about this, but yeah, so basically we have comments for immediate constants, shows some of the DARM interfaces. Yeah, so that was in progress, and we can see how in progress it was, because if we go over here, do we have it built at the moment? I'm not sure. 64. It is, but let's actually just give it a clean and then rebuild it, because I was doing a lot of testing last time, and I may not have. Oh, actually, I probably need to export Armadillo as well. I don't think I did that. RISC OS ammo build 64 one export. Just export that. Make sure it's actually okay. It's going to go and build it first. I should have done this beforehand, but no matter. Oh, that's taking a while. Oh, that takes a little while. Those are not terribly large files either. Oh, that's probably the slowdown on the first bit was probably just the I forgot what it's called. Docker starting up. Right, so that's now exported. Let's make sure that DARM has the same. So we have two libraries we base ourselves on. Armadillo provides the 64-bit environment, 64-bit disassembler, and DARM provides the other part, the RISC OS ammo. Oh, I know what this is. I need to put an export in here, don't I? Not that one. Not that one. Not that one. Oh, so many exports. That's the one I need to put in there, and that needs to go in both of them so that they both export to the same place. It's probably why it was so slow, because it was trying to do a lot of other things. But that's okay. Yeah, that's okay. Right, so what we need to do now is I probably need to go and just give that another export, make sure it did actually put it in the right place. Yep, there we are, all done. And this one, RISC OS ammo build 64 export as well. What? Oh, you've got to say which file to use on this one, because it's got multiple files. Files, make file, lib. One. There we go, it has already exported it, it's good. So with that in mind, now let's go and build this one with the module. Cool, we have the module built. So what we can do now is we can have a look at what the code looks like. So if we do a run pyro, oh, I've got some old ones in here. Code module im64/debugger dump hello world. There we go. So we do that one. I've left a GOS on the end of it, doesn't matter. Somebody suggested, do I work on the Linux kernel too? No, I don't tend to work on the Linux kernel these days. I have done some in the past, but only a tiny bit for my own purposes. Right, so disassembling this, we've got this one coming out with a number here. That looks like a number. That looks like a value there. This one here, yeah, these are all looking vaguely sensible. This one, however, looks a bit odd because it's giving me a negative number and that's a big number. What would be more useful would be if it told me that that was -16 there. But we can have a look at that. So yeah. So Benjamin's asked, what are we working on? So this is a disassembler for for ARM and ARC64, and I'm running it inside my own emulator to test it. This is all for operating system called RISC OS, which is what I developed for. And we're trying to make these numbers here look like these, look more sensible than this. This is the hex value, and it's given me the 2's complement version of that, which is not exactly helpful. But I think there's already hints in how this works and what we should be doing. Similarly, this one here has come out with -140, and that's a bit unhelpful as well. So if we go back to the code, we'll go to the code, and we find the bit that does this number decoding. So number decoding, I think it's at the end somewhere. No, it's not. Let me make that window a bit bigger so I can see a bit more. Right, number decoding. Right, that's this bit here. This is all C code, yes. Yeah, so this is the C code that actually implements the disassembler. And this is the stuff I've written. There's also code that was written by other people. The DARM library and the Armadillo library are written by other people, and I've integrated them into this this code. Right, so here we've got this is the disassembly that the Armadillo library has given us. It's told us that this is the information about the operands that were present. It says it's an immediate value, which is what that constant is, but it also tells us the type. It says whether it's an integer or an unsigned integer, which is quite useful because it means that we can actually go and do these things as a better description here. I just have a look here. So we've got IT positive. I'm not sure what that means. So if I just have a look, I wrote this code, but I can't remember it. So if I have a look in decode immediate, right. So it tells us that the value we've given it should be negated or it should be made negative. Right, okay. That's not quite what I was really intending to do there, meaning to have. But it's useful still, so we can do something with that. Yeah, we can do something with that. So let's go back to where we were. We're on the decode immediate. That's not the one we're in. We're here. Right. So let's try and do this a different way. So uint 64t is value is this. So this is the value that we've got from the disassembler. So Ryan's asked, assembling is something related to the CPU understanding assembler. Yeah, so let's give the background on this. So the assembler, the code that the CPU executes is all bit code. It's all got lots of different binary instructions. Those can be decoded into what is more readable. So if we go back down here, I'll show you these bits. So this one is a move instruction. It's a move the value 2 into register 10. And that's encoded like this as a hex value of, well, that number. We can turn that number into this string by disassembling it. Or you turn this string into that number, because I don't know about you, but I can't read that. That doesn't mean anything to me. So that's what the disassembler does. It turns the binary values that the CPU executes into things that a human can read. Okay, it's not very readable, but that's the intent. It shows us what we're trying to do. So yeah, making machine code into assembler, that's correct, yes. So here we go. We're going to try and do this code decoding here. So hopefully this will actually give us something that's more useful. So what I'm going to do is I'm going to try and make these conversions into something that is a little bit more helpful, which might be a bit complicated, I'm imagining. Int and long. How are int and long different? I'm going to assume that int is 32 bits and long is 64 bits. So we'll try and do that. So in fact, what we'll do is we'll just say what the value is here, and we will stick bits into this to make it look right. So if it's an integer, then the value is, you're quite welcome. I will try and explain if people ask questions, even if it's not necessarily at the same level, because not everybody knows everything. As you say, there are people who are new to doing things, and there are people who are more experienced. I'm doing this live coding largely because I enjoy it, and largely because it gives me a chance to go and learn how to present to people and to show people how to do things. It helps with work because it means I can mentor people better, and it also helps with understanding what other people actually understand. I can describe things hopefully better that way. Hopefully. Excuse me. So we're going to try this. This is a value for an integer, okay, and then we're going to it was actual, and then we're going to go if actual is less than 0, then how do I do this? I'm not actually sure. Oh, I feel very silly now. So I'm going to go, yeah. So yes. All right, let's do this. Oh, that's not helpful. I've got value labeled twice there. Immediate, we'll call that. Then that'll be more helpful. If immediate equals the bits. All right, so there we go, got the bits in there. If it's less than 0, immediate equals actual, or minus actual. And oh, I need to tell it what the conversion type is. Oh, I've forgotten what IT positive is. I don't know what that is. Copy, paste, search for that. An im type E, an im type T, sorry, that's one of them. Im type T is an im type. Oh, I've already forgotten what the values are as well. Oh, how stupid am I? Positive, negative, and negated. So, okay, there we go. Right. Here we are. This is about where we were. Okay. I have to remember what I'm doing some of the time. It's quite difficult. Right. So, im type equals im type negative. Else im type equals positive. Actually, I should probably sign that automatically so that we default to positive. I'm not sure this is going to work because I'm not quite sure what I'm trying to get to here. Right, so there we go. There's that one. And then we want to try and decode a else if Oh, maybe we should do this as a switch. I should do this as a switch, shouldn't I? A switch based on operand type, because there's 4 of them, and it will make it really easy. I can just do case like that, and then indent this, please. Dip, dip. There we go. Get rid of that bit, and we can just do it as a case statement, switch statement. There we are. Uint. In fact, all these are going to look very, very similar. Done. Hello, people. So we've got a lot of new people coming today that have not seen the channel before. This is quite nice. It's quite surprising having people that who've never seen this before. It's quite reassuring. Oh, actually, I've realised that's wrong. Else immediate equals actual, because I don't want it to be a really big number. Right, here we go. If it's unsigned, then it's the actual value. Yep, there we are. And then do the same for a long, which I'm assuming is a 64-bit. Excuse me. 64 actual value. Oh, except this isn't going to work on a. Oh, it's fine. We'll see what happens. We'll just see what happens. It's not gonna matter. If it's less than 0, then make it negative, and mark it as negative, and then do that, and then do that. Maybe that will work. I don't know. Let's build it and see. Build it and see. Oh, I'm sorry. Yeah, you can talk about SQL if you want. I don't mind. Have a chat about what you like. Right, let's build this and see whether that even vaguely works. Probably not. I suspect this won't work, but well, oh no, we've got bad things here. Duplicate case value. Oh yeah, I wrote the same thing twice. Oops. Wrong. There we go. Let's build that again. Let's see what we get. Almost certainly going to fail here. Note, value is declared here. What's wrong with it? Value may be used in uninitialized. Oh, okay. Just our value. What? I don't know what I'm doing wrong here. What's wrong with this? Decode immediate. Oh, yeah, okay, I know what I've done wrong. I forgot to assign it to anything. Decode immediate should be immediate, and it should be assigning it to value here. There we go. So that was, yeah, that would break. Right. What have we got? What have we got? Is it even going to vaguely work? Well, that didn't work because it said that that is 140, which is 140. No, the minus 140 is not 140. Minus 70 is not P. What was the other one it tried to decode? Minus 10 is not bit. So it hasn't actually negated these. That's not helpful. Maybe it should be. Oh, I think I see what I should have done. I think I see what I should have done. I shouldn't have actually. Maybe that. Yeah, I think that's right. Yes. All right. Oh no, I've just run the same code without actually building it. That's a little bit silly. Do that rather regularly, actually. It's like, oh yeah, your code doesn't actually work unless you compile it first. I work a lot with Python, so I don't have to compile things a lot of the time. And things end up being much easier to read when you don't have to compile them. No, now I've got the same blooming numbers. They're all... Oh, that's not right. So what? Is that because it's not sign extending it? I think that's because it's not sign extending it. They're small numbers, but they're not being sign extended. So I'm going to try if it's negative or OX 1, 2, 3, 4, 5, 6, 7, 8, shifted left 32. Wrong unsigned. And that one should already be correct. If it seems like I'm not quite sure what I'm doing here, that's because I'm a little bit tired and I'm just trying things out to see what works because I've forgotten how my code works. Yeah, that's not a genuine way of developing. It's a very poor way of doing things. Still doesn't blooming work. Okay, so I'm going to have to actually understand it to work out why it doesn't work. Right, so what does this code at the top here do? What does decode immediate do? It takes a value as a 32-bit value. Oh, interesting. Oh, interesting. Maybe it should take it as a 64-bit value. Oh dear. So we're getting it truncated anyway. But for these values, that shouldn't matter, should it? Shouldn't matter. So if I say that the number's negative, then we produce a negative value. And if it's negative, we put a minus on the front of it. Do we? Do we put the minus on the front of it? If it's positive, otherwise, if it's negative, do this. Hex value. Negate the value, negative value. My head hurts. I'm sure this made sense when I wrote it. It comes in as the positive value that you want to use, and type it is actually saying what we should be handling it as. Which makes sense. If it's less than hex 100, okay, that'll be big enough. Sorry, I'm thinking. It's hard doing thinking. Right, I think, he says, I think that is where I'm going. Oh no, I don't know where I'm going wrong now. Maybe I should have a different routine for the 64-bit. If I have a different routine for the 64-bit code, so I don't have all of this wrong program, so the wrong bit of code, this bit that's related to the decoding for 32-bit, then it would make it a bit easier to understand. I mean, I can use the same pattern. Okay. Yeah, staring at somebody who's getting confused is not helpful, I know. Maybe this should be as this is signed or this is unsigned. Oh, I don't know. Actually, what I'm going to do, here's what we're going to do. We're going to print out the values. We're going to print them out as we go. So immediate equals this. And type equals this. Yeah, all right, we'll do that. So we do immediate, comma, where's type? Operand to op-in dot type. There we go. All right, okay. Just do that, and then it might make a bit more sense what's actually going on. Lots of different things. Oh, look at that big negative number there. Look, it's minus number. Minus number's what I want to see. That number is what I want to see there. I need to find out what this type is here, don't I? So I need to find armadillo. Armadillo.h. Oh, all right, it's in adefs. Adefs.h. There we go. And it is, here we are. Int, uint, long, ulong, and then a float at the end. We're not handling floats, so we'll not worry about that. Where am I going? Yeah, I now need to go back here and go, right, so which one was the one I said was right? Which one was the one I said was right? So this one here, type 0 minus 192. So I want to get out 192 to that. Back to my code, please. Oh, my code's here, sorry. So I'm going to also pass in what I've actually given it. Oh, hang on. I forgot. Oh, here we go. I'm always passing in positive every time. I'm not actually passing in the actual type I want to use. So that's why, well, that's really why. So Rayan's asked, what does undefined instruction mean? Is it an error or code should do that? So that's a good question. So if I just, can I just take out my debug again? Just give me a second, I'll show you. So rebuild it and then put the, let's see this. Right. Oh, go away, I've written the code wrongly, give me a moment. I apparently can't write code. Here we go, rebuild, I'll show you. So within the instruction set, there's, as you saw, there's the big 32-bit values of instructions. So I built it a second time, that's not what I wanted. Right, disassemble it again. I could have scrolled up. Right, so these are instructions here. And as you can see, some of these are marked as undefined. Not all of these values have a real meaning to the CPU. Many of them have been defined, but some of them are not defined. And that means that if the CPU tries to run them, it will break. It will go and call undefined instruction. If you ever see an error from your computer that says, not general protection fault, but an execution fault, commonly, if you see a blue screen, that is one of these sorts of cases. But there are other cases as well. If you use Linux, you'll see it as a oh, I can't remember what it is. Oh, I've forgotten. It's an undefined instruction abort. I can't remember what it's called in Linux or Unix systems. Oh dear, that's really sad. But if it tries to do that, it will generate a signal to say that it can't execute it. Is it a problem? So if we have a look at this code here, here's where it actually starts executing. It's got a line of instructions here. And it goes, store some things, get an address, move some values, and then call a system call. This address here, address 98, is the address here, 98 here. And if you look at this, see 98, it gets the address of this, and the text of that is hello world. So it would print out hello world, because this is what the system call does. But the text hello world isn't actually a valid instructions sequence. So it does this random instruction here that doesn't mean anything in this case. Another one that doesn't mean anything, and then one that doesn't even have any definition at all. The string RLD and a 0 doesn't mean anything. So that's what an undefined instruction is. There are some parts of the instruction set that just don't contain values. Right. Anyway, let's try and see what we can do with this. I think I was doing this. I think, yes, I was here. I can put this back. Oh, I'll leave that off actually. I'll type. Right. I think this will work. Let me just try it. I'm not completely convinced. This is not the best way of doing it. It should probably be fixed, but we'll have a see. I hope that explains what the undefined instruction means. Right. Are we going to get some good values this time? Yes! Yes, we've got values that are coming out sensibly. So here, minus hex 10 has come out as minus 16. Minus hex 140, minus 320. That feels better. Using arc, fair enough. Right, so those values are now coming out correctly, which is a good sign. And since that is a good sign, I'm going to go and mark it as completed. So let's commit that code. Let's just check what we've actually changed. Hi, Dave. Right, so yeah, we've got this nasty conversion here because of how I've done the decoding instructions. Commit the code. Right. Fix for the negative constant values, or immediate values, sorry. not coming out on ARC64. Oh, I've just realized this isn't going to work elsewhere. The immediate values are now converted to the form that the decode immediate function wants. This means that when the disassembler produces minus OX10, we leave a comment of minus 16. Put those in quotes to make it clear. All right, so that will work there. But oh yes, of course I can send the repo link. If you give me a second. So this repository is this one, DOM. No, it's not. It's not that one. It's no. Yes, this one. Copy. Let's paste that on there. Using. Right. Yeah. So I've built this and tested it in 64-bit, but I haven't tested it in 32-bit, and it will break. There we go. It's breaking in many ways because uint64 isn't currently supported in my compiler, so it's not going to work properly. But we can cheat, because we can cheat. If def RISC OS 64, we do it this way. Could I actually cheat even more? Yeah, I probably could, but I'll just leave it for now. Actually, yeah, I'm going to cheat even more. I'm going to go and just do... Oh dear, I hate me sometimes. Let's define int64t, int32t, and sorry, you. I can hear people screaming. No, I can't hear people screaming, but I logically can. Okay. Oh, excuse me. I've done that back to front. That should be if not def. So if we're on the 32-bit compiler, we just fake them as being 32-bit values instead. Let's try this. So this is the 64-bit one works. What I want to do now is try the 32-bit version. And I want to dump that as 64-bit. I think that's the right syntax. Numbers are coming out okay. Numbers are coming out okay. So it'll only be massive numbers that come out wrongly, and we shouldn't have many of those. So that looks good. Oh, actually, no, that's not good. This is a horrible hack to allow the conversions to work properly on your cloth compiler. Okay. Commit that. Fix for the... Oh no, don't fix. Commit it with an amend, because it can go on to the last one, because it completes that change. There we go. Yeah. And we can push that change. Okay. And with that, we've now got the immediate constants commented properly. Woohoo! But he says, if I have a look at how the the 32-bit version looks, if I look at the 32-bit version here, we see that all of these values are coming out with hex here represented by ampersand rather than by the numbers. So I want to do the same thing for the 64-bit version. So if we look at the 64-bit version here, we've still got OX10, OX32, and so on down here. So I want to change those. I don't remember how I did it in the other code, so I'm going to have to go and have a look at how it was done in here, because surely we had something that was looking for tweak the hex notation, look for an OX. If we find it, just change it to an ampersand and copy the string down. Okay, that works. Let's give that a whirl. Hello again, Ryan. Yeah, so we want to do the same change in here. If I put that into a function, would that make more? That would make much more sense, wouldn't it? Let's put it into a function. Convert OX hex OX to ampersand in char star str. Yeah, so we manipulate it directly, don't we? Oh no, we don't. Interesting. Into new arg. This isn't quite what I thought it was, because we're copying into a new string. Bum, bum, bum. That's fine. We can do it. It's okay. Except I don't want to manipulate the buffer. Is that a const buffer? It is, isn't it? Fine. No. Copy that here. Right. Look for it in the string. The location becomes an ampersand, and then copy everything down from after that. Yeah. There we go. Yeah. And actually, we could put this in a while loop, so if there's multiple of them, it'll convert all of them. So while do the assignment in there. And then at the end, return struct. Okay. And I think we're always going to do this manipulation now, just because it's going to be easier to always do this. And then we do convert hex OX to ampersand of new args. Right. And this function can go way up at the top, somewhere up the top. Decode immediate, after decode immediate. Oh, I went, is that? There we are. Right. Convert hex OX to ampersand to OX number RISC OS style ampersand number. Okay. And that can be a static as well. We don't need to call it anywhere else. Right, convert hex. So this call here, we can now go and put into here. You just modify buffer. Oh, we need to modify the buffer before we start some padding on it. There we go. Args is not defined in the new function. Oh, thank you. Args is not defined. Yeah, thank you. That one there should be strush, shouldn't it? Thank you very much. All right, see if we can build that now. Probably not. Even with Dave, my co-pilot, helping, I've probably done it wrong even still. Oh, no, that seems to have worked. So, disassemble the 32-bit code and see we haven't broken it. Right, ampersands are still coming out okay. That's good. Now go back to the 64-bit one, build the 64-bit version. And check the ampersands there. Not that one. Come on, where's my 64-bit? There's my 64-bit. Well, that didn't work. Did I build it? Did it actually build it? I did build it. So this is the new one. Convert hex OZ. Didn't I? Isn't that right? Maybe I should do. Oh no, that's the spaces from the mnemonic onwards. It should have been here because that's where we copy the arguments, the operands. Yeah, like the comment says, in fact, we copy the operands there, and then we can manipulate it. Oops. That's okay. Just not reading my own code correctly. This is why I leave comments in, so that future me can understand what's going on. If future me forgets to look at the comments, then that's his own stupid fault. Right, we have some ampersands in there. Nice. That feels good to me. Right. Commit that. We haven't broken. Oh, we have. We've broken the end comments here. Oh dear. Ah, because the... Oh, right, okay. Because we've shortened the string, it puts the comment after where the actual end of the string is now. Out equals buffer bracket strlen buffer. There we go. There we go. That'll give me the end of the buffer. To resynchronize that, and then we'll have comments back again. Not bad. Build. Yeah, so the things like swise.h and the like, you wouldn't need to worry about because they're RISC OS specific. But the rest of it should be mostly standard C code. If you don't know much about C, then you'll have more difficulty, yes. Hey, there we go. Comments again. Yeah, that's right. Right, and we have the OX converted to an ampersand now. Whew. That was somewhat tedious, but it's working. Okay, let's commit it. ARC64 disassembly now uses ampersand instead of OX for X values. RISC OS users, so I'm keeping that format for this ARC64 disassembly. Right, and let's push that so that it gets run on there. All right, that'll get run in the CI system and it'll test that everything is still working. Okay, so we've had 50 minutes so far, and surprisingly, I'm quite tired already. I think I usually have an hour and a half, but I'm considering a break. However, let's just have a look at what we do inside the old code here. So this is the DARM code here, and it does disassembly. It changes SVC to SWI. Well, fair enough. And we do a lookup. Now, the problem with that is that SWI calls can't be looked up easily in the ARC64 code because the thing that you're looking up isn't the thing that's in the instruction. The SWI numbers are not there, so that's not going to be possible. Here we've got some magic that goes and changes hash plus into a address. That's fair enough. We don't need to do that. Same goes here. Address, another PC relative one there. That fixes that up. Don't need to do that. A little bit of a change here that gets PC relative things coming out differently. Might need to do that one. I'll have to have a check. LSL. This changes them to MOV instructions. Don't need to do that because the instruction set's quite different. Fixes for older style code, putting in the P on the end of it. Not an issue. Let's leave that one. Put the mnemonics into the correct case. Magic manipulation of RRX, which is just a DARM fix. And then, what's this? Oh, this is the negated negative conversions of things. So yeah, nothing special there. Okay, I think we've actually got this working quite well now. I mean, yeah, aside from a few of the horrible hacks and things. Okay, I feel relatively good about that. I'm not feeling that things are too bad there. All right, let's have a check and see whether the automated build worked. It's still running. It's still trying to do its test. Let's have a quick look at where we're up to. Whoa! Yep, it's still building. But the bits it ran at the beginning was actually testing parts of the code that existed. Ooh, wedding things. My fiance is working on very nice some other things for our wedding, and that looks wonderful. Excellent. Yep, there we go. Testing stuff. Still looking okay. And finished. Whoa. All right. Thank you, Ryan. Ryan, sorry. I keep saying Ryan. Thank you very much. So we're both very, very happy. Okay. So this actually exercises the code that disassembles stuff for 32-bit, but it doesn't exercise it for 64-bit. So the tests we've got in here are not complete, or at least they're not actually going to find problems, which is the entire point. So I need to have a look at what we do here. How do we do this? We build it through there. Oh, we just send it all off to the build service. Well, okay. I will never be divorcing C, I'm afraid. Fortunately, my fiance understands what I'm doing and how important it is to me to do these things. It's actually a really quite nice thing, because we're a bit older now and we both understand how important it is to have a good work-life balance and to be happy. So not taking my work home is important, but also doing the things that I enjoy when I am at home is important. And that means spending time with her and doing the code. Does she understand C? Yeah, she understands quite a bit of it. She understands what I'm trying to do and how it's working. So that's quite nice. And I can talk about the things the things that I'm doing. Where did I find her? About 40 years ago. No, it wasn't 40 years, about 30 years ago. About 30 years ago, when we were at sixth form, we met and we fell in love, and then we fell apart, and then we split up and went our separate ways, and we've come together a number of times, and this time it will work. We are much older, much wiser, and more sensible. But she spent time working in computing as well. She worked in a computer support role at previous places and did some security work in computing, so she understands these things, which is awesome. It also means that she can tell me when I'm going off on a rant. Older and wise. Yes, we're wiser. We are wiser now. I think we're wiser. Well, you're wiser. Anyway, digression aside, the important thing is you both have things in your lives that are important to you, and you both understand one another and can support them in that. So I try to support her and she tries to support me. And I'm very proud of her. I'm also very proud because she's, as I say, sorting out bits for the wedding whilst I'm doing silly code things. She's doing important stuff and I'm just faffling around with code. Yeah. You might be able to tell I'm exceptionally happy at the whole situation and how wonderful we are together. I think someone knocked a dial. Did I do something wrong? Sorry, that's a little loud. Yes, I apologise, Dave. I should stick to the coding, shouldn't I? Yes, I was saying to her just yesterday. I was saying, look, if I want to talk wedding things, I'll talk wedding things because it's all part of life. So, yeah, suck it, or something like that. I don't know. This is not your traditional podcast. I'm not telling you to like and subscribe every 20 seconds. Right. Distractions aside. Oh, excuse me. I love you very much, pretty girl. Right. Okay. I'm not sure if you can see how red I'm going now. did we actually check in the Hello World? Yeah, we do have Hello World 64. Exercise memory I. Coding 64-bit code. And relax. Wonderful. It's suggesting that if I haven't taught my kids to debug a GPU driver by the time you're 10, you failed as a father. Well, no more kids, thankfully, but right. Little reset. Yes. Yes, all I was trying to do there was add a little bit of test code so that I can exercise the 64-bit disassembly and show that it doesn't crash. Add a CI test for the I of 64-bit. Right, let us do that. One interesting thing, actually, so if we just build the 64-bit version, make sure it's built, yeah, and we've got the 32-bit version built already, I think. Yeah, got them both built now. If we have a look at the size of this code, rm*/*FFA, there we go. If we have a look at the size of them, so it's quite a big module, this. This is a very large amount of code to have in here. It's like 620K for this for the ARC64 version, which is massive. If we have a look at the original assembler version, the one that was actually shipped with RISC OS, which I have lying around in projects, RISC OS. Pyromaniac modules debugger. There we go, there's the module. It's 15K, so that's quite an increase, but I don't really care, because the point isn't to have like really dense compact code. I mean, that would be lovely, but the point is to have something that works. Something that works is more important than something this small. Maybe in the future we can replace the whole thing with something that's more table driven and better at it. But for now, that's absolutely fine, I feel. I'm really not caring. We can argue in the future about whether things work better. So, what Rayan says, what makes that happen? Partly it's optimization, partly it's the fact that the original ARM assembler was really well written. It was really well written for a specific task. However, it is really, really hard to understand and work with, and nobody has touched it hardly. That's not true. There has been a lot of work done on it, but it's not really a useful way of building that. So yeah, that's why that is there. However, having said that, the current debugger is built without many of the optimizations. So if we have a look in here in Makefile module, we can actually make it better than this. So if we're building the 64-bit version, too many dollars. I want to do, how do I do this? Is it C flags 64 minus 03? And I think that's how you do it. Let's just check. Build the 64-bit version. Again, I will need to delete the files, won't I? OZ64, delete the files and rebuild it. So I rebuild it with that optimization enabled. Oh, that didn't do it. Oh, I don't know how to do that. I can't remember how you do it. CFlag 64, I thought that was how you do it. Let's have a look. All that and move files. Okay, it's in rules. Minus 01. 01, no. So where's C flags defined? Is that defined in tools? It's defined in tools, here we go. C flags. C flags 64. Oh, I need to append it afterwards. I don't like the way this works. It doesn't make it very easy for me to understand. So I need to put this down here after the C module include, which isn't very nice. I need to tidy up how some of this works and document it properly. But let's give it a whirl. Delete the files and start again. Yeah, now it's trying to apply the optimizations to it. And this is only for this part of the code. The other Armadillo and DARM won't be applying the optimizations, so we'll need to export those as well. It takes a little bit longer when you tell it to optimize it a bit more, but not too much. Right, ls. Right, how big is it now? 612K. What was it before? 620? Where was it? I've lost it. 621. That's made almost no difference. Well, bother. Let's see what we can do with Armadillo. Makefile lib, here we go. All right. So we want to do the same thing for this. Pick this lot up and put it here. And then build Armadillo. So make, no, that one there. Clean it first and then rebuild it. And hopefully this will actually use the flags. Yes, there we go, it's using the optimization flags. Again, this will take a little bit longer. Maybe I should have a copt or coptimize switch that actually I just set that and it will use it. Might be better really. Right, that's nearly built. Excuse me. Come on, a little bit more. Just a little bit more. You can do it. You can do it. Min size rel. Minimum size for release or something like that. Sorry, Dave said CMake's equivalent is min size rel. I think that seems to make sense. Maybe I should actually have a release version and a debug version as well. That would actually be kind of sensible. Right, rebuild this, relink this with the new did that not export? I should have exported it. I think I've forgotten to use the export that we had over here in this file. Export that one. I need that line in here. Is that what was wrong? Yes, that's what was wrong. All right, ls. What's it look like now? There we go. That's much better, isn't it? That's massively improved it. And that's only Armadillo. So we do the same here. So make this clean for DARM. I've used Meson for things. It's quite useful, quite good, but it is a bit of a learning curve. I mean, CMake is also quite a learning curve as well. I have not spent time with it myself. Most of the bits that I've learnt recently, I've learnt from Dave. But unfortunately, there isn't a port for RISC OS, so we're I'm a bit limited on what I can use in these tools. Right, that's DARM, sorry, updated, and now, oh yeah, that's because I didn't actually change the, I didn't change the make file. DARM/makefile lib. If you don't change the code, it won't do anything. There we go. Right, let's try that one again, shall we? Clean. And rebuild. One of the problems with all build systems is that you eventually hit their limits, or you want to do something that's a little bit too special, and it becomes difficult to work with. Most of them have ways of doing stuff, but it's really down to how common you're doing things. Right, that was building it with 03. So now if we go back to Debugger here and relink that, we should get 333. So not as big a jump as with Armadillo, but still quite significant. So that means that the 64-bit version is actually smaller than the Norcroft 32-bit version, which is kind of nice. You want to say the more time you use them, the more complex they get. Yeah, but a lot of the time it's the more you use the tools, the more you go, oh, I could do this, oh, I could do that, or I need this particular feature, and then you end up starting to build more into it, and it becomes more difficult. So it's still, yeah, and also as you start doing more clever things, you start hitting the boundaries of what it's good at. So that's the other reason why it's useful to start splitting things up and doing things more modularly. But the more modularly you do it, the more you have to use your build system to be able to help you to use the new modular system. So it can get quite hairy. Yeah, anyway. So let's actually do that. So let's say we've done that now. Update the 64-bit build to use -03. The, what's it called? Armadillo and DARM libraries will also need this as well. These are before this change of all three. The size of the 64 module was 621K. After all three being optimized, the size is, I've forgotten, 233K? 333K. You could also argue it means that the default optimizations that are done in GCC are not very good. I mean, one or the other you can argue, it's fine. Right, push that, and I need to push the same for the other two. So git diff here, yeah. Add optimization for 03 of 03 for the 64-bit build. Qt cuts the library size in half. Push that as well. Yeah, fine. And this one as well, DOM. And the optimization -03 to the 64-bit build. Did I try minus OS? I haven't. I could give that a whirl, yes. Optimize for size. I'm never sure what the right way to do that is, but we could try it. Just let me get this committed and I'll build all of them and we'll see what happens. Something else I can say there. Right, let's have a push that. We'll just try tweaking it to be lib OS, you said. Dave suggested trying minus OS. So let's just try this. Let's go do the clean first. And then export. And export. Okay, that's all pretty fast. That's very fast, actually. And then we'll do the same with Armadillo. Yes. Yeah, it might be an idea to actually have an optimize for size, optimize for speed, and optimize for max or something like that. I don't know. It'd be useful to do something like that. Right, clean. And then export. There we go, minus OS this time. And whilst that's going, I can update the makefile here. Because nothing says efficiency like having to change the same thing in 3 places. Just like I'm not going to worry about it. Clean. Build 64:1. No makefile module. Are you still building? You're still building. Ooh, a little bit slower there. Right, and then build this one. Oh, there we go, that's build this one. Come on. I'm expecting to see big improvements here. 333 was the value we were trying to beat. What do we got? We got 301. That's actually not too bad. I genuinely don't know whether optimizing for space will slow it down at all, or whether it will be better or worse or whatever. I just don't know. I guess this is part of we could do benchmarking on it. I mean, the other part of this is 300k still too big? I mean, maybe it is. I mean, yeah, maybe it is. I don't know. The original was 15k. It's now, what's that, 6 times bigger? No. 300 divided by 15. 20 times bigger. Okay, I can't do maths, but that's a lot bigger. Do I want to commit the change for size? Yeah. It's not a big deal, really, is it? It's got a size in there. Nobody saw. Right. I think that might be worth committing because it does make a difference. Makes quite a difference. Yeah, go on. Was it 301? I think I said 301, didn't I? Yeah, 301. Dave tells me that his private eye image viewer is also built with OS. And that's pretty damn fast. So yeah, I think we'll go with that. Yeah, that's a good plan. So I think this is better. There we go. And then I need to do the same for the armadillo again. Bum, bum, bum. And commit it. And DOM. There we go. So that's now done there. Push that. Did I push the other one? I did. And I pushed that one, didn't I? Yes, good. Yeah, so we're all good there. Okay. And that I should really check that this is actually working, shouldn't I? Yeah. I'll need to make sure that those libraries get exported, but in general that should be now working. Okay. So if I go back to my task board, the things that I've got left are actually quite involved. There's another one I wanted as well. So that's just tidying up the code. I'm putting that one off, I'm afraid. Debugger swise and flags. This probably isn't too hard, and we should start looking at that, I think. Creating some CI for 64-bit is important, but I'm not going to rush to it right now because I've got CI in my own systems. The other one I wanted to do was add proper testing for the debugger module. Thank you very much. In the debugger C1, yes, using the blank template. We've got an empty template there. That's not very nice. Right, copy. Oh, come on, where did I put it? So projects row RISC OS 64 status .github pull request template. There we go. And copy it to .github. So this is a template that I try to use on things. So if you have a look at it, GitHub pull. So this template basically has a changes sections and a testing section. The idea is it encourages you to write something about what you've actually done that's relevant, which I've just realized won't matter because this is an issue. There is, however, an issue template, isn't there? There is an issue template. Well, I'll commit this one anyway, but I'll work out what the issue template is. Add a pull request template to the repository. The template encourages good form when writing pull requests. Now, okay, so GitHub issue template. How do these work? Configuring issue templates. Default community help. Oh, that's those ones. Yeah, I'm not worrying about those for now. In the features section, click Setup Templates. You may need to enable issues. We've got them enabled. Setup templates. Huh. Okay, well, let's do that. Right, in the settings. I've forgotten what it said. It's this one here, isn't it? Settings, drop down menu, then click settings. Go to features under issues, setup templates, features. Okay. Not that one. Not that one. Hang on. That's the wrong repo, that's why. I want to be on this one. Settings. Scroll down to features. Ah, here we go. Issue template. Set up templates. Here we go. Add a template. A feature request template. Preview and edit. This file lives in feature request.mv. Okay. About, so just an idea for this template. Template content. Is your feature request related to a problem? I don't care about that one. For now, project doesn't have a license. You're right, it doesn't. It should be under MIT. I should add one. Let us do that. Additionalize default title. Enhancement. I'm going to just go with that. I'll see how it looks, and we'll sort of work on it. So propose changes. Update issue templates. New feature. It's the first time I've used them in this repository, so we'll see what happens. Commit directly to master. Yeah, might as well. Go for it. Right, now, so the template exists. Sorry, no, I want to go back to the test board. So I want to try creating add proper testing for the debugger module. If I do that, I now get a feature request one here. And then it says this one. Whoa! Is your related to a problem? Please describe. There is no real testing for the module. We just run things and check that it doesn't crash. We should use some gold master results to compare against. And test both the 64-bit and 32-bit interfaces. That was created for Pyromaniac and used in message trans is a good start. Okay, there we go, create. All right, so that's there, and we can have a look at that shortly. The other bit that was suggested by, was it Rayan? Rayan mentioned that we don't have a license on it. Yeah, he says we don't have a license on it. So we should put a license on this. If I remember rightly, so if we look in DARM, DARM here has BSD3 clause. And if we have a look at Armadillo, Armadillo has BSD3 clause, which is handy because it now means I may as well use BSD3 clause. Let's go do that. Add a file, please. I thought you could. I think if it does, if you choose a license template, there we go. Yes, all right, let's get on with it. Choose a license template, BSD3 clause. Bum, 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 bum. 2025, full name, Charles Ferguson. I label my things with Gerph. That looks like the right license. I'm happy with that. Must retain the above copyright notice. Redistribution in binary form must reproduce the copyright notice. Neither the name of the copyright holder nor the names of its contributors may be used to endorse. Right. So, redistribution in binary form must reproduce the above copyright notice. So we have to include a copyright notice to say that it's BSD3 clause. So let us do this, shall we? Review and submit. Dum dum dum. That looks good. Commit changes. BSD3 clause license, same as the libraries we include. Okay. Ta-da! Right, so that's one thing, but now we also have to do add license details to the binary distribution. Feature request. With the changes, with the libraries all being BSD3 clause, we are required to include copyright notices in the binary. So we should include them. The task manager acknowledgement interface allows us to include these notices. We should include it here. Yeah, I think I should update the README as well to be clearer what's going on. I'll do that shortly, or I might actually update the README offline, so I'm not doing it in these sessions. I try to do a lot of my coding in these sessions, but I don't think the README file is all that interesting for people to watch somebody writing it. Writing code is far more interesting than writing documentation, I think. You wrote ages ago. Is this log maybe? Right, so that might remind me where I need to look for that. All right, so these two look like things that I can do next. I will actually add the note about update the README to reflect reality, because it's a stub at the moment, isn't it? The README file isn't very clear what it is or how it works, etc. Expand it. We should include, what should we do? We should include the names and links to the libraries we use, what the repository does. I think I should do this with a task list. It's much more useful. That does come out right, doesn't it? If I put it in preview mode, yeah, that looks okay. What the repository does. How it can be used. Right, any additional context? No, I can't think of anything. Right, create that one as well. Yeah, there we go. All right. Okay, so we've got 3 separate things here that are actually quite good to do. Can I move them to the top? No, can't do that. It won't let me. So, got 3 things to do. However, it's now been an hour and a half, just over an hour and a half, so I'm going to go and take a break. Ooh, I'm going to push this first. Oh, no, I've got to pull the changes because we've made changes to the repository, haven't we? Set up stream. Pull. Yep, there we go. Yeah, because we've got issue templates been added, license has been added, and this is my one that I'm doing for pull requests. Push. We have a look in here. We should see. Now got a pushover template, and this is how the issue templates work. Ah, right. Ah, that's quite neat. It's a YAML format. Looks like YAML format followed by a bit of Markdown. So that's quite nice, actually. I don't mind that. Right. So with that in mind, I'm going to go and take a break. What I normally do before I take a break is I give a quick summary of where we're up to, which means if somebody spins back in time, they can just see this. So far today, what have we done? We've, I don't know what we've done. Oh yes, we've fixed the ampersands. So we get hex numbers in hex. We get numbers in comments coming out as comments. We've updated the optimization to do things a bit smaller. And we've updated some of the maintenance for the system as well, the feature requests and the pull requests code. And we've created some issues for the next block of work to do. So that's good. All right, so it's going to be about 10 minutes, usually about 10 minutes I do for my breaks. I will see you back in a moment. Well, look a while anyway. So, okay, break for 10 mins. Back at about 2:55, I think. Maybe a quarter now then. There we go. Yeah. See you in a bit. Hello, hello, hello. I'm back. Took a little bit longer than I thought. I wanted to grab some food and things. Right, let's see what we can do. Right, we have some little notes here to say what we're trying to do. So, first one we can do is get a license in there. That I've suggested. I've left myself a note, didn't I? I just left myself a note that task manager acknowledgements can do this. But I just have to find out where I've left that code, because I don't remember where I've left. I've definitely written it. I've definitely written it before, I just can't remember where. So let's go and have a quick look around, because almost certainly I'll have it somewhere. Tools like projects, RISC OS, not present, it won't be in there. It would be in modules, RISC OS source, sources, programmer, hardware support. Not hardware support, syslog I suggested, didn't I? Syslog. So let's have a look in the CMHG file and see if it actually declares it in here. Task manager acknowledgements. Here we go. Good. Good, 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 good. So let's have a look at this the sources here. So what I'm going to do is I'm going to put these things side by side. So this one's going to the right hand side, this one's going to the left hand side. And we're going to have a look at the CMHG file that tells us how to handle things. So let us have a very quick summary of what task manager acknowledgements is. In fact, I'll show you a little bit of what it does. I'll show you the command line version anyway, because there's a version that's in the actual desktop, but I'm not using that at the moment. So if we go into command line here, this isn't actually available on standard RISC OS, but here. So task manager acknowledgements is the command, and it gives you a list of different things. The name of the component, and then you can give some details of what the acknowledgements should show. And you can extend this really quite easily. Well, relatively easily. Yeah, so that's how that works. And the way that it does it is we issue a service that goes out to the world, to all of the components that are running, and they can respond and say, hey, I've got this result that you can look at in some way. I can't remember how it does it, but we'll go and have a look at it. So that's what it does. So what we can do here is we can go to service call handler, mod service, task manager acknowledgements. That's the one there. And we're going to put that into here. Do we have a service handler in this? There's the service handler. So just replace that one. There we go. Mod service, task manager acknowledgements. Okay. And then we need to find where the acknowledgements are. So I assume that they're in here. Mod service. Here we are. Task manager acknowledgements has an add messages function, and then it calls it with this. Good afternoon, Andrew, and there's nothing wrong with playing Hexen. So, for anybody who's just joining us, like Andrew, I'm adding in the acknowledgements for the license terms. So I'm stealing the code from syslog. I'm going to put it into the debugger module. Just dump it at the end. Oh, no, not at the end. Just in here. Commands, before the commands. Command handler, here we go. Service handler. Right, so this has task manager acknowledgements. It must be getting this task manager add messages function from somewhere. I don't know where. I wonder if it's in here, in this file. It's not in this file. So Oh, and apparently we also have to let Task Manager know that they've changed. Oh, I didn't see that. Let's just dump that in as well. So we need to do that when it exits. Here. No, that's not very nice. That's better. And the same again for initialization as well. Initialization. There we go. So just give me a second. I was going to put this code in here. Ryan has asked a question that is unrelated to the debugger, but is a part of the general engineering thing. So he says, something I'm struggling with is software design or architecture. When I start a project, I don't know how the file structure will be. So that's the problem. Don't know how to solve it. So some of that comes with practice. Some of that comes with just trying stuff out and seeing what happens. But the way I approach things is to, so if I want to build something, I've usually got an idea in my head of what I want. And in general, there's two major ways that you can attack it. There's a lot of ways you can attack it. You can start from the top down and working out what you want to see as a user, or you can start as the bottom part and work out what it is you need to do to make that happen. And I like to work from the bottom. So I like to go from the, I'm trying to think of a good example. So I'll take the example of this debugger module. I knew I was going to create a debugger module. I knew I was going to have interfaces to talk to things and the like, but that wasn't where I started from. I didn't start from build a module and then try and build that up to have the disassembly in it, the debugger parts, breakpoints and all the rest of it. I didn't start from that. I started from the point of I need a disassembler. I will port a disassembler. I will then make that disassembler look kind of like what it would do in a module. And that was the starting point, was to just get something that works and then start to bring it in. So that was how I attacked that problem. As for actually file structuring, so one of the things that you'll notice here is that, I don't know if you can see this, but the list of files that I've got, there's quite a few files here. We started out with RODIS, which was the RISC OS disassembly module. And all that did was just hook into the DARM module. That's all it did. It didn't do anything else. It just took that data and made it into the form that a debugger in RISC OS would need and be able to produce. And then after that, it started being expanded, so it could also do memory disassembly and things. And so it started adding new little bits to it. And then I found I needed things like to be able to do floating point disassembly. So I added in some floating point disassembly. And I knew that I wanted to be able to disassemble files and things that were directly in memory. So I created this thing called I/O, which was able to access both memory and files in the same way. And that was actually originally inside RODIS. And then when I found that that was getting a bit large, I moved it out to its own file. So it was separate. And then I/O handled just the, how do I get some bytes from something, either memory or file, and how do I access it? And then I can just use it from within the disassembler in the same way. So I started just building it up and splitting things out as I needed to. I knew some of the structure that I would need, but I didn't start out by putting that structure in at the beginning. I put in a little bit, but not the whole thing, because it was likely to change. If we have a look here very briefly at disfile, so disfile is very, very simple tool. All it does is it passes some command lines, calls in, this is RODIS, that function is in RODIS, this function is in RODIS, this one is in RODIS. All of them just take string input and they produce some parsed output to say, this is what I'm trying to do. And then here we go and dump a file, or we disassemble a file. And all those do is just call into RODIS. This is just a big wrapper around that. all of these functions are used inside the main module inside Veneer, but I could test it all out in one particular file. So that was how I sort of built this up, getting larger and larger as time went on. Which is one of the reasons why I've done this series, was so that people could see how you build something up to be something much larger and hopefully useful at the end of it. So I hope that answers your question a little bit. It's not perfect, but yeah, Ryan's just said, so do anything and polish it and the structure will come by in time. That's basically it, yeah. You'll also find that as you do things, particularly early on, it ends up being messy. You end up with things that aren't right, and that's fine. So you'll have seen, oh, where did I leave it? It was in the armadillo, this bit here, I think, in Rodis. We'll have to fix me. Yeah, so there's fix me here that says assume the data is aligned. There's another one here that's same again. Another one there. Yeah, this is a horrible hack. It's like, leave yourself notes so that future you can come back and go, oh yeah, I knew that was going to be a problem, or I didn't like it, or I thought there was maybe a better way, but I didn't care at the time. If you try and do everything perfectly straight off, it's not going to work. You're going to spend all the time polishing it and trying to get it right early, and you won't get to the point where you've got something that's doing the job you need it to do. It's wonderful if you can see the whole and be able to go, right, I will get to that point. And sometimes I can do that. Sometimes I can know exactly where I'm going to, and I'll not even have to plan it out. I'll go there. Other times, you're just like, oh, I'm going to try this out. And you might end up throwing stuff away. I mean, there's been times, I don't think on this one. Actually, yes, there was on this. So when I originally did this, the parsing code, this bit of code here that did things, I think it was. No, I don't know. It might have been the floating point disassembler. Yeah, I think it was in here. Originally, I had a bunch of functions that would go and construct different strings together and put them together in different ways. And as I was doing it, I thought, oh, this is awful. Why is this so bad? And somebody, it may have been Dave Thomas, said to me on the chat, like, it seems like you're just building a formatted string printer. And it was like, yes. And I just deleted the whole lot and started again with this new form that uses snprintf. And suddenly it's so much easier to understand rather than the mess of code. So sometimes just trying it out and realizing you're doing it wrong is part of that design process. Yeah, Dave telling me that I've done it wrong. But just try things out, see what happens, try and make a different pattern of doing things, and you'll learn what works and what doesn't. I mentor people at work, and that means teaching them how to do things, what are good ways of doing things, and they'll ask questions, and they'll say, well, why do you do it that way? Because sometimes they have different experience to me, and I'll go, oh, I don't know, that just seemed like the right way to do it for me. Maybe it's not. Maybe we'll do it your way. Maybe we'll try it that way and see what happens, and we'll see whether there's any problems with doing it their way. Or you can explain to them, this is what the problem is. If you do it like this, you'll not be able to do this thing, or this will work better, or that will work worse if you do it your way. And then you can discuss and go, well, actually, we don't care about those things. There's a principle in software engineering called you ain't going to need it, which means don't try and build technology that you won't need later on, because you may not. Sometimes you'll know you do need things, but other times, if you're building something that isn't part of your goal or part of what you needed, you're just wasting time and creating something that's going to break and bite you in the ass later. Anyway, that's my sort of view and sort of very quick précis of how you do some of this development work and design work. Sometimes you can work on it. If it's a larger project, you can actually put a proper design together and try and make sure that things are done in a more structured way. But this wasn't one of them. Right, anyway, sorry, I was distracting myself from something or other. What was I doing? I was putting in these service calls, yes. So you'll see a little bit of that as we're doing this now. I just need to work out how to do this. There's no problem with being a noob and accepting that you are early in your development. I am a noob on many things. I don't know how to do a lot of things, and I will find that people will help me when I'm at work. They'll tell me things that I didn't know. Even at my age, or particularly at my age, actually. One of the important things is to know that you don't know everything. And it's something that my fiance reminds me of as well. But no, it is important to know that you make mistakes and you say, well, I think this, but I could be wrong. Or there could be a mistake here. Or I might not be seeing the whole picture. Those are the sorts of things. Right, okay. What I was trying to do was work out where this comes from, wasn't it? Because that I've got. And presumably it's actually in an include in here. Copyright Gerph? No. RISC OS. Switcher.h probably. Is it switcher.h in here? No. Interesting. I wonder if it's in the RISC OS. Rolib? Maybe? I wonder where switcher.h is. Hang on a second. Let me get to my... Discuss kitten. h.switcher. That's where it is. Okay, so we can include that then. So if we include switcher, actually it doesn't go there, it should be, this is one from the libraries. And so that filing defines what the acknowledgements service is, and defines these functions, which is good. So, system, tertiary, commercial, freeware, and user. That's really helpful. I don't remember what those mean. Service, task manager, acknowledgements. No. Feature documents, PRMs. I don't think that the RISC OS that was not how you spell it, but service task manager. Oh, look at that. Oh, look at that. They haven't actually described the priorities in here. Icky. Right. So it looks like. Okay, since that's not the one, I'm sure I wrote an app note about this. I'm sure I wrote an app note about it. Service calls in the library, that's there. Service. That's all I've said. That's helpful. Well, I can't remember where it was. It's a little bit large. Let's bump that down a bit. I can't remember where that was, so I'm going to just put it in and we'll see how it goes. Okay. So module title is there. And we've got to retain the copyright string. So let's have a see what the copyright string was. Copyright string here is, yeah, like that. I may not include the year. I don't think it's really necessary to include the year. Copyright. I don't want to put copyright Gerph there, do I? Debugger module, copyright Gerph. Armadillo library. I need to find the Armadillo library. Less license. That's the one, yeah. How about that? Try and keep the same style. And what was the DARM library? Same thing. Yeah. License. Julian Barmer. There we go. Okay. So that'll handle the service for us. Don't need anything else. And that issues a service to say we started up. Okay, let's have a see what happens when we build that, shall we? Oh, come on. That's the one, build it. Oh. Yeah, we need to include another header there, so we need to include switcher so that it knows what the value is as well. Dum dum dum. Drop us into GOS. Task manager acknowledgements. Debugger. Debugger module, copyright 2025 Gerph. Armadillo 2019 Justin Sherman. And DARM library, copyright lowercase c. I'll put it in capital C. Maybe put them both all in lowercase. I'll put them all in lowercase, I think. I think that was the recommended one anyway. There we are. Cool. So that's now included in the acknowledgements. So we are now compliant with our license, which is quite nice. Commit -a. Add notifications for the task manager for the license through no, oh, that's not right. LED, the copyright statement in the binary distribution. It might actually be nice to call the library to say what its license is, but for now that's probably fine. Or its copyright statement is. Right. Okay, now what I'm going to do is I'm going to split this up because the acknowledgements code is in the middle of all of the module code, and I don't really want to be doing that. So what I'm going to do is I'm going to create a new file called acknowledgements. I'm going to move the code into there. And partly I'm doing this because Ryan was asking about how you structure stuff. And partly I'm doing it because as I was writing it, it felt like the right thing. So what I'm going to do is I'm going to move those bits of code into here and then call them. So it's isolated into a separate place. I think I was making a cup of tea. I have a feeling I left my cup of tea downstairs. I was making a cup of tea, wasn't I? I made a cup of tea, forgot to put sugar in it, and then I made myself a Coke. I'll go and get it later. Right, so this is my acknowledgements file. What we want is nouns. Cold tea is just fine. I realise I'm in a very small minority with this. Void. There you go. Hello, Eli, or Ellie, not sure how you pronounce that. Acknowledgements. Announce. Declare. Parameters. None. Oh, I don't know actually. Not sure what we should be here. Void. Not sure how I should do this. So, no, not that file. This file. So let's take the switcher call out of here. So we're not going to do this in here. Mod service. That's what I'll do. So what I'm trying to do here is basically take the code that I had and make it into something that's a little bit more generic. So that instead of having everything built into there, we can now, oh, this is not very nice. Is that right? That should be there. Yeah, that's right. So we can now just call these functions. Service number equals to do here is this one. Oh, I'm not even going to do that. I'm not going to provide that as a thing there. What I am going to do is make this one be there, like that, and then move this all into a string. Static const char. I'm not sure it's the best way of doing it. Maybe I should have it as a registered function or something. I don't know, but this is the way I'm going to try it anyway. So what should happen is when this acknowledgement service is called for this thing, it'll call the function that was supplied, and we can then supply the group, the title, and the acknowledgement string. This announcement here needs to be a SY call, which was this one here. Cool. Start up. And actually, we don't need to care about that. It's not important. Hash include stud bool and include swise.h. There we go. Should be all the things I need there. Now there's nouns and the service. So nouns shutting down, and this one is a nouns starting up. Ooh, a noun. What the? Those are not the correct letters. Sorry, Eli asked, what's the function? So what's the point of this? So this is to make sure that we are in compliance with the license terms of the component. So this debugger module uses some additional components, two libraries, DARM and Armadillo, and those two components are able to be used within it, but they have a license that says they must declare their copyright string. So this is providing that copyright string notification, which I think we should be all good with now. I just need to include the header and then we're okay. So in theory, I can now pick up that acknowledgements file and put it in another component, and it will be able to be just very much the same thing. That's the idea anyway. I need to copy this, duplicate as H acknowledgements. Thank you. You stop spinning. It's thinking. If def acknowledgements. That can go, that can go. This is just setting up the declarations. And I think that's it. Right. Let's build it. Oh. This is going to fail because I haven't actually included the acknowledgements file in the linkage, so it will fail to link. Yeah, just add it to the end of this. It looks like that's not lined up properly for some reason. Is that because of probably tabs, isn't it? Let's just Ooh, I didn't mean to do that. Didn't mean to do that. There you go, nicely lined up. Yeah. Okay, cool. Rebuild. He's got, oh, who's a naughty boy? Who hasn't included const on his declarations? That was wrong. All right, we'll remove the const from that just because. I want to leave the const on it. It's a constant string. Shush. Let me do a Charles direct. Yeah. Past me was rather lazy, apparently. What was the other thing it complained about? That was wrong. Module title undeclared. So the module title comes from modhead. Oops. Include modhead.h. And null hasn't been declared. That's because null is in studlib. I think it's in studlib. I think it might be in one of the others as well. Maybe studdef or something, but I'll include that anyway. Studdef, it actually says it should be in studdef. I'll leave it as studlib because I tend to use studlib for that. Right, test it. Drop me to a command line. Test manager acknowledgements. It's working exactly as before, but now all of the acknowledgements code is in a separate place, and we just call it with the right functions, which is quite cool. I think it's quite cool anyway. Right, so let's go and make sure that that is in source control. Add c/acknowledgements and h/acknowledgements. Is there a reason why I use test manager acknowledgements rather than putting it in the module's help strings? That's a very good question, actually. So the module help string has, usually people tack it onto the end of things saying copyright these people, but no, I don't think there is a good reason. I think the main one is that it becomes more visible, and that was what acknowledgements was for. Should I put it on the help string? Don't know. That's a very good question. Interesting. I don't know an answer. I could certainly do that, but it might be nice to actually have some thoughts on where things should be. A lot of the time, trying to make it putting things into the test manager acknowledgements was there so that we can see them in the desktop. That was the main thing. Yeah, so Andrew just said, how do you view them in the desktop? So if we go to let us show you where it turns up. I'll just need to finish this message and things, so we can reuse the code elsewhere. Right. So you've seen the command line version. Let's build the module for 32-bit. Right, 32-bit module coming up. And if we just copy this module into hostfs in RPCMU, and then here we are, here's RPCMU. we have a look in here. Here's the debugger module. Load that up. Go down to here, info, click on the info, and you can see all of the components. And here we are. Here's debugger listed with the new copyright strings there. So it sits in line with all of the others in there. And that gives us information on how that should be working. Sorry, there's bings going off. No, none of that interesting. Well. Except for Dave being funny. Yeah. I have no idea if that's how RISC OS 5 does it. I have no idea if that's how RISC OS 5 does it. Yeah, well, I mean, if they can't be bothered to support the things that are there, then that's fine. Yes, they could, almost certainly there could be a command line tool that does that. There's no reason why somebody couldn't issue a service to pull that information out. Should probably create a module for that. Although it should be in Test Manager, it just should be there. Debug. Well, it's not debug. I don't want to have one that's just for debugger because it's a lot of. Then you've got hundreds of different things. The idea was it was become centralized. I'm a little surprised that RISC OS 5 doesn't do that, as there are a lot of components that need to acknowledge their details. RPCMU 5. Let's have a look. Screen sharing. Here's RISC OS 5 coming up. No star. There's no star command in the. There's no star command in RISC OS select either. The only reason that it exists in Pyromaniac as a command is because otherwise there's no way to view it. But do they not have anything on here? That's odd. As I say, they're. So if you go to the documentation, also known as service get credits. Why the hell would we know it as get credits? Its name is Task Manager Acknowledgements, and that was what it was documented as. He said, yeah, it's only documented as 4.6. Interesting. So Nemo's documented it, basically, it looks like, because he has his own magic thing. Yeah, so apparently they just haven't done that. Yeah. But it would be not too difficult to make that get collected and provided as information, probably. Right, anyway, that is fine. Kill that, stop the sharing. Right. Shared sound includes it. Huh. Didn't know we documented what was listened for by modules. Fair enough. Anyway. Ooh, you segfaulted. That's not very nice. Don't know why I did that. No matter. So we've now got the acknowledgements present. Cool. Push that so we've got it in the external sources. And this is now complete. Licenses done. Next bit is add proper testing for the debugger module. I've got 20 minutes left until I'm done with this session. So do I have time to do that, do we think? Probably. Let's have a see, shall we? Right, so what have we got in here? We have got some test code in here. This test code is it's just a list of immediates. It's nothing particularly special, and that's all we've got in there, just so we know that we can disassemble them. Module in absolute. Yeah, sorry. Yeah, there's just nothing in those, is there? Okay. So nothing in there either. All right. And the make file here has got how to build stuff, and then the tests from message trans apparently. Okay. Well, let's. So the module is debugger. Transform power tests and build service. So this is clearly code that I just copied from message trans some time back. So what I'm going to do is I'm going to just mangle it for this and then see what happens, because why not? So I'm going to need this script here, transform pyro test to build service, and the actual debugger tests. So let's do that. Copy, I just find message trans, projects, row, modules, RISC OS source, sources, not hardware support, sorry, internationalization, message trans 2, test code. So there's something called run on build service that needs to come into here. And what's the other one that I said I needed? Transform pyro test to build service. Okay. And anything else? Probably tests and test.pl as well. Okay, I've copied them into the wrong place. I meant to put them into test code. Oops. Build service, test.pl, transform test.txt into test code. All right. Right, let's have a look at test.txt. So we want to actually run debugger. And now we need to get some debugger tests. So let's copy them, project/ro/pyromaniac/testcode/tests debugger. That one there, copy it to here. And what's the other one? The swise call, I think I said, didn't I? Debugger swise. Let's just get that as well. And we'll have a look at what those tests incorporate. So this one, test the debugger, we use bin debugger, so let's get we need to get the debugger test code as well. So s/debugger into the S directory. And let's have a see what's in there, because that probably needs some things. Swise, macros, and print macros. Swise, macros, and print macros. Okay. If we do a make now, it should build us the debugger code, hopefully. I need args common, apparently. Copy that as well. Args common. So this the debugger test is the one that we've seen before, where we run with -d to disassemble the instructions. So if I just demonstrate that, private dev common load module debugger, and then run debugger FFC with D. This is the code that goes and actually exercises. Oh, I couldn't spell module. There we go. And it prints out things like that. So that's the one that we had. If I rebuild it now, there we go. We should see in the bin directory we now have a debugger, and the debugger code that's out here can go. And header, sorry, S and header and bin. Okay, so we've got some of these things. Just need to work out how to use it. Those files need moving because they want to be called tests pymodules. It has to be called tests debugger pyro. So this is, the idea is that this test file, this one here, is exactly the same in RISC OS Pyromaniac and in the code here. Unfortunately, that also means that I need to do some of this testing for some of the exception conditions. Probably I want to just disable those. So disable. Is it disable or is it skip? I don't know how it works. Skip. No, is it disable? Yeah, disable and then a reason. Let's just disable these ones. Oh, we can't. We also can't handle input. Yeah. This is going to need a little bit more thought because input isn't going to be supported in this way of testing it. Debugger finalization. Yeah, we need to disable all of those. Star memory. Got some random data I'll need to put in there. That's fine. We can put that data in. All of that looks okay. All of that looks okay. Can't do input. None of this can work because we've got no input support for memory A. Oh, actually, that only matters for the ones that actually have input. That has input. And these are all memory I's, they look okay. Memory I's for thumb. Dumping modules, init store. Yeah, fine. Vector doesn't exist in this version of debugger. Maybe I should include that. It's actually quite a useful function. Oh, but it's hard to get to the information about. Right, and then just comment the other two out because we're not going to use them. All right. Okay. Yeah, no idea if this is going to work. No idea if it's going to work. Let's just see what we can do about it. In order to run this, what do we do? I don't know what we do. Did we have a make file or something? Oh no, that's the Pyro one. I didn't want to look at that. Yes, there's a make file there. Copy the make file. Oh, I've already got a make file, haven't I? Make tests. No rule to make test debugger. Oh, that's because I've missed one. I've missed something on it. Yeah, that one there should be debugger. There we go. Make tests. Well, that doesn't seem to be working. No! Oh no, it did actually work. Oh, that's interesting. It's just it didn't have the expectation file. Okay. I need to copy that file across, but it shouldn't be in the so expect / debugger, and then cp. Not that one. Oh no, it was cp from there. So I was trying to copy it from Pyromaniac. I want to copy expect / pymodules debugger show regs mod. You know what, I probably want to copy all of those files into expect debugger, and I need the conversion tool. It's got message trans in there, that's why. I wonder if I should even include that. There we go. No idea if this is going to work. We're guessing here. See you, Ryan. See you, Ryan. File message trans not found. That does imply to me that maybe I've got it built in somewhere that I shouldn't have. Run on build service. Load module. Load message trans, yeah, there we go. Load debugger. This is not quite the most well set up. What's the name of the terminal that you're using to interface? So this is Apple's terminal application, and the shell I'm using is Fish. That didn't work either. Okay. What have we got wrong here? Oh, we've got another reference to message trans. So debugger, no problem. And bin / debugger. Try again. Yeah, I'm editing this all on a Mac, I'm afraid. So it's one of those things. Minus commands not found. Yeah, this needs a bit more thought, doesn't it? Because it's not quite. I'm trying to run multiple commands here, and they're not doing the right thing because probably need to move them into here. $line is command args. Args is what? Args is whatever we were given. Right. Yeah, so this is going to do minus quiet, and then this, which isn't going to work. However, we could make this work. We could do that, I think. Oh gosh, does not work. I can make that work, yeah. So we run through the arguments, okay. So the problem is that when I execute it on the command line locally, it has one syntax that says run these things. And when I run it on the remote service, it has a configuration file, which we build here. So what I'm going to need to do is build the same sort of configuration file that we can actually use here. And I think the easiest way to do it, oh, this is going to be complicated. Oh dear. Right. Yes, I can do this, but it's going to be a bit more complicated. Am I going to do it now? I don't know, because I've said that I was only going to do about 3 hours worth of coding. If I do more than that, it's going to get tiring and people are going to get bored. I'm going to get bored, but I want to get this working. Let's have a quick run through it. So we want to turn all the commands into things that can be run inside the build service or switches. Config. Is into something like does that look right? I think so. Not then do. So now I'm going to go and try and process that. Because we all love a bit of shell coding, don't we? If $1 echo. No, it should be a quoted thing. Echo *** run. Oh, we can't know what the command is until then. Next arg command. Yeah. Oh, okay. That quiet is important apparently. Sorry, I'm trying to rattle this off quickly and just get it done and not talking. I apologise. So the idea here is that we're taking the command line string and we're turning it into a Pyromaniac build job, row build job that can be passed to the service. That's the idea. Whether it'll work or not is not a matter. Yeah, so there's some additional bits here, but we're not going to do that. For line in dollar bracket lines do. We've got the line. We don't need to have that in there. We can just do that. Don't need the extra args. Probably. I have no idea if that's going to do anything useful, to be honest. Let's have a quick see. Nope. 118. I missed a fee. Oh, because it's not fee, it should be done. Okay. Nope, that's breaking quite badly. First one, however, did seem to do something useful, which is interesting. Oh! I mean, it wasn't, like, correct, but it was definitely working. But this one's got failed to do that. I don't know what's going on there, that's a bit weird. Let's have a look at the temporary row build file that it created. Which doesn't exist because it's deleted it. Let's not delete it. All these did actually run though. They did actually do something, which is quite nice. I mean, it doesn't look like it's the right thing, but it did do something, which is good. Have a look at the row build file there. Yeah, because it's just loaded the module and then it's done nothing else. That's why it's not doing anything. That's curious, isn't it? If it's quiet, then shift, otherwise do that. We're doing next target. I think I'm going to just leave quiet on. Quiet was false, just so we can see what's actually been generated. So we've also got some missing files. That's not a problem. We'll look at that in a second. All the lines. Here's a command. It's config, do a config. Comes in here, does commands, signs it into there, and then returns. Each time it shifts it off the end. You know what I'm going to do? I'm just going to do exit 1 there. Oh no, not bad. Exit 1 here, so we just get to see what the file would be. And then we can have a look and see. Yep. Load module, load debugger. Not even doing anything. What is... Are you not able to pass the arguments? While it's greater than 1, do this. Checking $1, next arg equals $. I'm a little bit concerned that that's given me a... What's that warning? Use $bracket commands to... I think because command is a command. I think that's why it's complaining about that. I didn't want to shift the first one, that's why. That looks better. No, that doesn't look better. Let me copy that file in. Specs, yes. NC replacements. Oh, we don't have any NC replacements, do we? I don't want coloured output. Coloured output is not supported. What's the desired result? So the desired result is that we have it running all of these commands on the remote system and giving us the output. However, that's not working at the moment, so it's possible I may end up just having to abandon this and move on to it later. I can show you the original one. So no coloured. 1 second, just let me save that. Right, new window. I should have shown this before. So if I go over to projects, row, not there, internet, message trans. So in message trans 2 we have test code please, the same process. So we do make tests here, it runs the same thing and it will go and call the commands on the remote system and tell us whether something's gone wrong. So it goes and loads all the files onto the remote system, runs them, and then tells us whether things have worked. Now some of this is, you see this doesn't use minus command, it uses follow on, so that's a little bit different. But this is actually running it on a server in AWS that's actually testing all of the commands. But it builds us up a new file called row build, which then has got all the right commands in it, but it's not working here. I wonder if I should do this offline, because I'm not really giving much benefit to anybody else. Yeah, I'm going to try to attempt this offline and see whether I can get it working. I'll post up the results next week because it's a bit more complicated and nobody really wants to watch converting shellcode. I'll post the differences up, the changes up on the repo when I'm finished. But I'm not going to waste people's time by dragging them through what is essentially building a test harness for this. In theory, the test harness that I've got here should be usable for all the other modules as well. That was the idea when I did message trans, but it was clearly a little bit too tailored for just this system at the moment. So we're going to have to tweak it anyway. Yeah, so I'm going to do that. I'll do that when I'm offline. So let's give a roundup of where we're up to. Yeah, let's do a roundup of where we're up to. So what we've got is RM32. We've got a 32-bit module, we've got a 64-bit module, and they're now doing the disassembly of ARC64 and 32-bit with comments and with the ampersands coming out properly and things like that. So my usual thing is to copy these files. Copy RM. No, not that. No, no, no. Oh gosh. RM64 then? Oh, that's interesting. It doesn't. Oh, going very slowly here. Copy rm32/debugger and rm64/debugger into projects row. It's got 64 status rm. Oh no, it goes. They've got different directories. All right, we'll do them separately. rm32 and copy rm64/debugger into projects. It's got status rm64. Dum dum dum. Yep, there we go. It's copied over there. So this is the RISC OS 64 status repository. Oh, I can't type. Yeah, and I've just added updated debugger module, so I can commit that. Update the debugger module binaries in the repo. The new debugger modules have comments about immediate constants in ARC64, and the comments and the ampersands replacing the OX strings, and it's much smaller, down from 1K to 301K. Okay, and then we can push that. And in case you haven't seen the RISC OS 64 repo, so this is RISC OS 64 status. I'll just go to the top of it. So this is the repository. It's got some binaries for 32-bit and 64-bit modules there, and it has a description of what they are, so how to find them. There's also a plan now shown, which indicates how I planned out doing this, and a description of each of the phases of development. So I've described what to do there and how it works, and some of the things that aren't relevant. The simple module and stubs we're in phase 1 at the moment. So if I look here, part of the goal of this is to get debugger to be functional, which it pretty much is now. And this is all nicely described here to say that, look, we've got the debugger, now functional module. There's a bunch of things that still need to be done for this phase. but I'm working towards some of these. So you'll be able to check those if you wish to. Fingers crossed I'll be able to get some of those bits done in the next few weeks. But it takes time, and it takes time just to like write out the plans and try and explain myself. I've tried to make sure that I explain myself on the RISC OS Open forums as well. But if something isn't understood, then please drop me a line and I'll answer rather. Okay, that is it for today. I'm going to tweak the run on build service and the parts of this that are meant to work in automation. And hopefully we'll get something out that's useful. If I can make it work, of course. Right, for now, that will do. Yeah, next week we'll have a look at probably the results of this and some of the other bits in the task list. I may start, I mean, I know I've said this like past 3 weeks, 4 weeks even, 5 weeks maybe. But I may start switching to another module or doing something different with my coding at the weekends. Again, if people have any ideas for what should be done there on RISC OS, please let me know and I'll have a look at it. Okay, thank you very much for watching. Sorry that's been a bit boring towards the end. I had hoped I could get this working more easily, but apparently not. Yeah, that's life. We'll see you next week. Again, 1 o'clock on a Sunday, I expect. If there's a change, I'll post it on the RISC OS Open forums. See you all later. Bye.